With Houdini 19 moving to Python 3, I designed some new tools that I've wanted for a long time. Let's see what they can do. The first one is called prefix suffix. What I do with this one is I select a whole bunch of nodes, come up here to this dialog, and I can type in some string and apply it as a prefix or a suffix to the name of all those nodes. This can be really handy when you want to just wildcard things in your op. Sometimes you might pick up a hastily made or extremely complicated script with a lot of long wires in the scene. I find this much simpler. I built this script where you can select the node at the top and come across to local merge, then choose either a relative or absolute path, and it will place an object merge directly underneath it, which you can then connect here and have much shorter wires. This can keep your scene a lot cleaner and free from overcrowding. Sometimes you have a setup where you need to export multiple components out for a render. In this case, I built a script where you can select all of the output nodes of things you're going to want to render and click Create Render Nodes. What that'll do is create geometry nodes at the object level, which contain all of your renderable objects, with an object merge inside pointing to them, a material node set up, and the render flag switched on for this, but the display flag just set to a null. That way these things never display in the viewport and slow you down. Also, geometry velocity blur is already switched on. If you work like me, or you're building a tool, perhaps you like to have certain networks at the object level. What this copy network script does is allow you to select a network and give it a name. In this case, I'm going to call this materials and bring my material context up to the object level. Sometimes I want to render depth of field in the actual render itself. In this case, what I can do is select my camera and create a camera focus here. This basically lays down a null that allows me to set the focus point for the camera. What that's doing is setting up a distance expression here between the distance where the camera is and where our null is. Then if we turn on enable depth of field in our mantra node here, or any other renderer, you can see we get depth of field rendered in our camera. Here I have a grid. I've put some noise on it, given it some point normals, and then scattered a whole bunch of points so they inherit those point normals. At the object level, I've got 3 test geometries that I want to instance onto these points. All I have to do is select my incoming points and select base instance setup. I'll come in here and select the objects I want to instance onto those points, and it'll create me the whole setup. In the first wrangle, I can come in and modify my p-scale, change the seed if I'm not happy with the result. In the second wrangle, I can also change the seed if I'm not happy with which objects instance onto which points. I also have everything visualized with this check instance node here, and an instance node set up here at the object level. Here I have some pieces that I want to smash up. I can click base RBD setup here, and it'll create me the entire network. I can set some initial attributes up, such as the initial velocity and angular rotation. I also have glue constraint network set up automatically, and then I can run my sim. The original pieces will then inherit the movement from the RBD simulation, allowing you to make some modifications to the geometry in this stream here. This network uses a simple rigid body solver, packed objects, and a glue constraint network. Sometimes I want a smoke network set up really quickly, rather than having to place the same nodes down over and over again. So here I can go base smoke setup, and everything's set up for me. I also have a sparse version for when I need that. In both instances, the attributes are all set up in a wrangle here, with the exception of the velocity, which is set up in a point velocity node for the curl noise. Both setups come with a ground plane and gravity already placed in. And post-sim, they're converted to VDBs, and the velocity field is merged into one field. Sometimes I want to control the bounds of the smoke object based on what's actually being fed into it. In this case, I can select my smoke object and run set smoke object size. I then select the object I want to reference in this dialog, and the expressions are all built for me. It also adds this extra tab, bounds padding, which allows me to scale the bounds in each axis. This is set up by default when running the base smoke setup script. And those are my tools. If you're interested in any of them, they're now available on my Gumroad. Thanks for watching.